Just like with numbers, we say that one monomial is a multiple of another if we can write a product of two monomials that looks like this. Our given monomial times something, some monomial, gives us the multiple. That is, to say that some new monomial is a multiple of the given one is to say that the given monomial is a factor of the new monomial. So let me give you an example. Consider this monomial multiplication sentence. 6x squared yz times 2xy squared is 12x cubed y cubed z. This multiplication sentence tells us that 12x cubed y cubed z is a multiple of 6x squared yz. So we define multiple for monomials the same way that we do for numbers. We define common multiple the same way we do for numbers. A common multiple of two monomials is one that is a multiple of both of the two monomials. The same holds for 3 monomials or 4 monomials. We also define the least common multiple of two monomials. But here we have to be a little bit different from the definition for numbers, since we can't really write the monomials strictly in order. The least common multiple of two or more monomials is the common multiple that has both the smallest possible coefficient and the lowest possible degree. So let me give you an example. The monomial 12x cubed y cubed z is the least common multiple of 6x squared yz and 4x cubed y cubed. Why? Well, the number 12 is the least common multiple of the numbers 6 and 4. And then if the degree of x here was any lower, it wouldn't be a multiple of this monomial. If the degree of y were any lower, again, this would not be a multiple of this monomial. If the degree of z were any lower, this would not be a multiple of this monomial. So because we can't eliminate anything in this common multiple and keep a common multiple, this is the least common multiple. Two things to be aware of. It is definitely the case that any two monomials have a common multiple. If all else fails, we can just multiply them together. This is just like the case for numbers. Also, just like the case for numbers, though less obviously so, among all the common multiples, there will be one unique least common multiple. That's harder to see than it is for the numbers because we can't just write all of the common multiples in order, because we can't really write all of the monomials in order. But there will be one unique least common multiple for any pair of monomials you pick, or any longer than two monomials list of monomials you pick. Unlike the case for numbers, though, we can't just make a huge list of multiples of each monomial and look through and pick. Why not? Because if we're going to try to list all of the multiples of some monomial, we're going to be here for a while, because we're allowed to introduce new variables. So if our monomial is x squared y, well, we can start with x squared y times a, x squared y times b, x squared y times c, and so on. And that doesn't even start on listing coefficients. This just isn't going to work out. We have to use the same method that we do when we're finding the least common multiple of numbers, using the prime factorization. And this is actually way easier than it is for numbers because monomials are basically already factored right out of the box. So if, for example, we want to find the least common multiple of the monomials 3a squared b to the 5th and 7a b to the 7th c cubed, well, what would we do? Noticing that my coefficients are prime, so I don't need to worry about factoring them. My least common multiple, well, it's going to have a 3 in its prime factorization. It's going to need 2 a's in its prime factorization. It's going to need 5 b's in its prime factorization. So these are all of the factors that it needs to be a multiple of this monomial. To be a multiple of this monomial, well, it's going to need to have a 7. It's going to need to have at least one a, but it already has 2 a's. It's going to need to have at least 7 b's. It already has 5 b's, so it needs 2 more. It's going to need to have at least 3 c's. It doesn't have any c's at all, so it needs 3 more. What do we get when we multiply this? Well, we'll have 3 times 7 is 21. A squared, b to the 5th times b squared is b to the 7th, c cubed. Notice what we have here. The coefficient is the least common multiple of the coefficients. And then the power of a is the higher of the 2 powers of a that we see. The power of b is the higher of the 2 powers of b that we see. And the power of c is, well, it's the only power of c that we see. So the power of each variable is the highest power of that variable that occurs in either of our monomials. And that's just what it takes to be the least common multiple. As far as the least common multiple of the coefficient goes, if you don't feel like computing the least common multiple of the coefficients by hand, you can use your calculator. Notice if I bring up the math menu and select num, scroll down to number 8. Number 8 is the least common multiple. So I could find, for example, the least common multiple of 6 and 8 on my calculator. I see that it's 24. Just like the greatest common factor, these need to both be positive numbers because the calculator can only compute least common multiple for positive numbers. So I'm going to give you one of these to try, finding the least common multiple of 2 monomials. Find the least common multiple of the monomials 8x squared yw cubed and 14x y squared z. Pause the video and try this now. Alright, a little bit of arithmetic gives us that the least common multiple of 8 and 14 is 56. And then x's, I'll need x squared over here, x to the first over here. The higher power is x squared. Y over here, y squared over here. The higher power is y squared. W cubed over here, no w at all over here, so I'll need w cubed. And then no z at all over here, z to the first over here, so I'll need a z.